Recording in progress.
If I write this statement, if P, then Q, and I ask you for the converse of that statement, what would you say? We switch around, exchange the hypothesis and the conclusion, if Q, then P. What's the inverse going to be? If not P, then not Q. And what's the contrapositive? If not Q, then not P. Good. It's the converse that I want to focus on here for today, because what we're going to do is actually take all those postulates and theorems that you just learned with parallel lines, and we're going to look at the converse of them. So let me show you. Before I give you any papers, anything, let's just go through this together. I made this up for me to go through with you together. Got your bad paper? Probably wrote your bad paper. Does anybody need a bad paper? Okay. So across the top, I've got parallel lines. You can see all these lines have triangles on them like this. And what we're going to do is go through those postulates and theorems from section 3.2, the stuff you just used to do your quiz for today. So postulate 15, if we start here with postulate 15, it says if, and in this case, it's lines P and Q. If P is parallel to Q, then what do we know about the corresponding angles? Well, yeah, that's true. Forget about the converse for just a second. If these two lines are parallel and I draw this transversal, then all the pairs of corresponding angles have to be what? Congruent is what we're looking for there. Congruent. So like this angle and this angle. All stuff that you've been using, all stuff that you know. For theorem 3.1, if P is parallel to Q, then what do we know about the alternate interior angles? They're also congruent. Like that pair right there. For theorem 3.2, if P is parallel to Q, what about the alternate exterior angles? They're congruent. So like this angle and this angle. And if P is parallel to Q, by theorem 3.3, what do we know about the consecutive interior angles? These are the only ones that are different. They are supplementary. So if I call this like angle X, and then I call this angle Y degrees, then I know that X plus Y equals 180 degrees. Stuff you already know. In section 3.3, down below, in this box of postulates and theorems, you're going to find the converse of every one of those. So this one's saying if the lines are parallel, then the corresponding angles are congruent. So the converse, or postulate 16 on your bad paper there, says if you got these two lines and the corresponding angles are congruent, like they are in this diagram, then we know the lines are parallel. P is parallel to Q. It's the same stuff, just the converse switched around. It should be. So, well, no, it's not all we're doing. Theorem 3.4 then says if you got two lines cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. Theorem 3.5 says if two lines are cut by a transversal and the alternate exterior angles are congruent, then the lines are, the lines are parallel. And this last one says if you got two lines cut by a transversal and the consecutive interior angles are supplementary, so again, the label of X and Y, it said they add up to 180, then the lines are parallel. Okay, that's what we're going to look at here to start. Let me get you a handout we'll fill in together. I'm going to pause the lady again. So looking at this handout, the first section says, is there enough information to prove that lines P and Q are parallel? If so, state the postulate theorem you use. And you look at number one. They tell me that this angle is 90 degrees and this angle is 90 degrees. What kind of special pair of angles are these? Corresponding angles. And they're both 90 degrees. So is that enough information to say that those lines have to be parallel? Yes, by what? Yeah, so be careful because now we're working with that section 3.3 stuff. It's the converse of all those other ones. So postulate 16, corresponding angles, converse. Number two, what kind of special pair of angles we got here? They're both 60 degrees. So is that enough information to say the lines parallel? Yep. By what postulate theorem? Theorem 3.4 says if the alternate interior angles are congruent, the lines are parallel. What about number three? What kind of angles are these? Alternate exteriors, they're congruent. Do the lines have to be parallel? By 3.5 tells me those have to be. You try 4, 5, and 6. It could be no.
Oh, we're got tricked.
Maybe,
Okay. Maybe what?
maybe. Call me.
We were just talking about calling people on our phones
Hmm.
in Spanish.
Oh.
Right, Bruce?
Hola,
Bruce said it.
¿cómo
Oh,
estás?
She said, hola, baby.
Hola, baby.
Yeah, Riker said sometime.
I like that too. What kind of angles are these in number 4?
Corresponding.
Now, they don't tell you what they measure,
But X and X have to equal the same.
but
thing.
they're both X degrees, so they have to be congruent, so the
Yes.
lines have to be parallel.
Possible.
Yes, by postulate 16, good, those are corresponding angles. 5, what kind of angles are these? They aren't, they're nothing that we have any postulates or theorems about. I guess we could call them like consecutive exteriors maybe, but we don't know any postulates or theorems about the consecutive. So just because they're congruent doesn't really tell us anything. Although, wait, what do I know about the
Yeah.
vertical angle to it?
It has to equal. So
That has to be equal. And what about the vertical angle to this?
Oh,
Okay,
Lord.
so what kind of angles are those?
alternate interior. This is consecutive interior.
Consecutive interiors. And if the lines are going to be parallel, what has to be true about the consecutive interiors?
They each equal. 180 combined.
Well, they have to combine to make 180 degrees.
So
But
it's
if
a
they're the
yes.
same.
Do we know that?
No, because it's not. Yeah, we do.
Because they're the same.
If they're the same, does that mean they add up to 180
Wait.
degrees?
Mr. Schubert.
I know, I
You're
know.
putting us on and then you're cutting us off.
I
This is
know.
not-
So you're right. If they're both 90 degrees, then they're the same and they add up to 180. Do we know they're both 90 degrees here though?
Mr. Schubert, is it yes or
Like,
no?
could this be 89 degrees?
Oh, well, yeah.
Could be. And then would they add up to 180?
No.
So even though we know those consecutive interiors are congruent, we don't know that they are supplementary. So can we say these lines are parallel? No, that one's a no.
Had that at first, and you're like,
I kept my no on.
and then you were like, wait,
Yeah.
what? Like, no.
I like to consider everything.
Oh.
What kind of angles we got number 6?
Uh,
And they are congruent. I don't know what they measure, but I do know they're congruent. So can I say the lines are parallel?
Theo, 3 point.
Yes, by theorem 3.4. Not yet. It's coming though.
3.6.
The section down at the bottom is stuff you've already done, but thinking about it backwards. You're gonna think about it a different way. What you're gonna end up doing is the same stuff, but you're gonna think about it backwards. It asks you to find the value of x that makes m parallel to n. In all the algebra stuff that you've done previous to this, you already knew the lines were parallel. Now we got to find the value of x that makes them parallel. Well, what kind of angles are these? And if those lines are going to be parallel, what has to be true about alternate interior angles? So how would I set up my equation? Yeah, they got to be the same. So if I divide by 2, then x equals 40. So when x is 40, the lines are parallel. What about when x is 39?
Nope.
What about x is 41?
Nope.
No, only when x is 40. You try numbers 8 and 9, and I'm gonna answer the phone.
Oh,
You try 8 and 9.
sure. Yes.
That goes. That's wrong. Find the value of x that makes the lines parallel. It's the same stuff, just backwards. Just thinking about it backwards. Oh, Zach.
It's gone now.
Want to chase him down and give him one of those?
Front eye.
Chase him down and give him one of those.
This is the one time you get.
You get to run in the hall. No scissors though.
Yell at me. Yeah.
What kind of angles are these in number 8? They are corresponding angles, and if lines are going to be parallel, what has to be true about them? They got to be congruent. So I would set up my equation by saying, I like that, divide by 4, and x equals 30. What kind of angles we got in number 9? Consecutive interiors. And if the lines are going to be parallel, they have to be what? Yeah, so this one's the only one that's different. How are you going to set up your equation? I like that. We can add them together, set them equal to 180. So 3x plus, what's this, 90? Equals 180, take away the 90. We got 3x equal to 90 and divide by 3. X does equal 30. When x is 30, the lines are parallel. What about when x is 31? No.
30.2.
Yeah, what about 30.2?
That'd be closer. But
It would be
it's-
close.
no.
It still no is correct. So go to the next page.
Good question.
9.9 repeated.
Yeah. Use a diagram and the given information to determine if M is parallel to N, P is parallel to Q, or neither. Those are your choices. Those 3 things I just put in a bubble. You got 3 choices here. So number 14, they tell me that angle 2 is congruent to angle 11. Well, here's 2 and here's 11. If those 2 angles are congruent, is that going to make any of the lines parallel?
That's parallel to that.
Which one's a transversal for these 2 angles? P is a transversal cutting through lines M and N. And angle 2 and angle 11 are what kind of special pair angles? Alternate interior angles. And if they're congruent, does that make lines parallel? Yeah. By what theorem?
We don't have to use.
You don't have to tell me here, but it is theorem 3 point,
Sorry.
which is
Is
guessing.
it 4?
I think it's 3.4. So if 2 is congruent to 11, then M is parallel to N. Try those 3. We'll check them in just a second.
Oh,
Okay, the next one. I lost my other pen. Here it is. Tells me that angle 1 is congruent to angle 8. So that one and that one. What kind of special pair angles are those? So right now, I don't care anything about these over here. What's a transversal? M cutting through which 2 lines? And if those alternate exteriors are congruent, then are the lines parallel? Yeah, P is parallel to Q there on number 15. Good. Number 16 says 10 and 14. Kind of special pair angles we got over here, 10 and 14. Those are corresponding. What's transversal?
Wait, is there recording in progress?
Yeah.
And I missed it.
N is the transversal cutting through which 2 lines? P has to be parallel to Q again. And then 4 and 16. 4 and 16 are what kind?
I said.
Yeah, they're really
Parallel to
not.
that.
What would be the transversal that makes both angle 4 and angle 16? There isn't one. To make angle 4, you need this line and this line. To make angle 16, you need this line and this line. Got to be a neither. Now, here's where, what if I said this? What if I said angle 3 is congruent to angle 5?
That would be. Well,
Then that would be
well,
wrong. Well, unless they were each night.
Is M parallel to N, P parallel to Q, or neither?
Wait, 3 to 5?
Yeah, 3 and 5 are congruent, I'm telling you.
Well, you can't prove that it's.
They are what kind? They're consecutive interiors. Do we have a theorem that says if the consecutive interior angles are congruent, the lines are parallel?
I mean, technically speaking, they could both be 90, but you don't know that.
Yeah, we don't know that. So the theorem says they have to be supplementary. If I tell you they're congruent, doesn't mean they're parallel. You'd have to say neither. That's a little tricky. You might see that on assignment or quiz. Oh, look at this. Oh, look at this.
Oh,
It's a proof.
yes.
but it's like a training wheels proof. It's not that bad. We just gotta fill in the reasons here.
Given.
Okay. Okay, good. It says complete the two column proof. Given that G is parallel to H, so they're telling you that these two lines are parallel. That's what those triangles are indicating. And that angle 1 is congruent to angle 2. So I know that angle and that angle are the same. Prove that P is parallel to R.
God, this looks awful.
Okay, they do tell me, they start right out with G parallel to H, and that is given. We know that. Then it says 1 is congruent to 3. So this line and this line are the two that we already know are parallel. And that makes this a transversal, and angle 1 and angle 3 are what kind of angles? They are corresponding. So what? Yeah, it's the stuff from the other section that says if the lines are parallel, then the corresponding angles are congruent. So this is going to be postulate 15. Okay, that's true. Then they told me that 1 is congruent to 2 by,
That was the one that took me the longest because I forgot that it gave us.
oh yeah, there was another part. Now, how do I know if 1 is congruent to 3 and 1 is congruent to 2? That 2 is congruent to 3. I disagree. Now, I see where you're coming from. 2 and 3 are corresponding angles, but do we know that P and R are parallel? No, in fact, that's what we're trying to prove. So I can't just say that these are congruent by postulate 15 because that requires that we know the lines are parallel. There's got to be another way.
No, we're not going back to those.
If 3 is congruent to 1 and 1 is congruent to 2, whoa, we already did that part.
Wait, what are you?
You're right.
It's
If-
something about like equal.
If I know that 1 is congruent to 3 and I know that 1 is congruent to 2, you could substitute that 2 in where the 1 is.
Okay, what you want to?
The substitution property would work. I would also take transitive. Transitive would also work. What would be the middleman you're cutting out?
One.
The ones, right? If 3 is the same as 1 and 1's the same as 2, you cut out the middleman and say 2 is congruent to 3 by transitive. That would work too. Now, because 2 is congruent to 3, we just proved that. Now we can say that P is parallel to R by what postulate theorem? That's the one that we learned today. Now that we know those angles are congruent, we can say those lines are parallel. It's gonna be up there. It's a good one.
Mine's theorem 3.7.
That's coming right now. I didn't pay him, I swear. What does theorem 3.7 say? We want to read it. Okay. If two lines, here's a line. And if I got two lines that are parallel to that line, so I'll draw one that's parallel to it like this. And I'll draw another one that's parallel to it like this. What has to be true about these two lines? They're parallel to each other. It's really just the transitive property. If this is parallel to this and this is parallel to this, then these two have to be parallel. And I could do this all day long. What if I drew another one?
No.
What if I drew another?
It's broken.
If this one's parallel to this one, and this one's parallel to this one, this one's parallel to this one, this is parallel to this one, what's true about these two lines? I don't know what happened there. That one we did. Thank you. Thank
Why are
you.
some of the lines short? Well, the line segments that are drawn.
Yeah, I like to mix it up a little. Number 19, bowling lanes. A recreation center has 4 bowling lanes, L1, L2, L3, L4. Each lane is parallel to the lane immediately next to it. Explain why the first lane, L1, is parallel to the last lane, L4.
Theo Rum.
Theo.
3 points.
Okay, I'll write it down there.
Works for me. Works for me.
Theo, 3.7.
Okay. So the converse of all of those postulates and theorems allow us to prove that the lines are parallel if we know some stuff about the angles. We're going to cram in section 3.6 into this little section as well, just because it's all mostly stuff that you already know, and it's not going to be worth taking a whole day to do it. Do you want to take a quick little break before we do 3.6? All right, see that. Hit the restroom, go get a drink, get the Max box, whatever you need to do. Yeah, so on the back of your map paper, you're gonna find section 3.6. There's some theorems about perpendicular lines that go with this section. Help me remember what perpendicular lines are, though.
90-degree angle.
Okay, they intersect form right angles, that's right. The first thing isn't even a postulator theorem, it just tells you, we're gonna use this word as a new vocabulary word. I know what you know, I know that you know what distance means, but when it says the distance from a point to a line is gonna be the length of the perpendicular segment from the point to the line. So, wait a minute, if I draw a line, and then I draw a point not on that line anywhere, how about right there? If I wanted a distance from the point to the line, it says it's the perpendicular segment from the point to the line. If I just draw this distance like that, well, not that part, just to there. That's the distance from the point to, in other words, if you were to go from the point to the line like this, is that the distance from the point to the line? No, that doesn't make any sense.
It just says that you have to have a straight line.
Yeah, that's pretty much all that's saying. Now, look at theorem 3.8, 3.9, and 3.10. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Whoa. Two lines intersect to form a linear pair of congruent angles. What's a linear pair, first off? Okay, they're adjacent angles, good. Adjacent angles that add up to make that straight line are 180 degrees. Now, this is saying that it's a linear pair of congruent angles.
Saying if they're both 90 degrees.
If I got two lines that are intersecting to make a linear pair, like this one, let's call this angle 1 and this angle 2. If I tell you that this angle is congruent to that angle, then we know those lines have to be what kind of lines? Perpendicular. That's all that's saying. If those linear pairs are congruent. Theorem 3.9 says if two lines are perpendicular, so we're starting out with perpendicular lines, then they intersect to form 4 right angles. Well, we know they make one, but what's the vertical angle to this one have to be? And what's the linear pair to that one have to be? And then the vertical to this one has to be. So if you got perpendicular lines, not only they form one right angle, they actually make 4.
That's like one less than 5.
True.
One more than 3.
And 3.10 says, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. It's like they took all the vocabulary words and just threw them all in one sentence here. If two sides of two adjacent acute angles, what does adjacent mean? Right next to each other, what does acute mean? Okay, so if we got two angles stuck right on each other, they're both acute angles, and two of the sides are perpendicular. If I draw an acute angle like this, and I draw an adjacent angle to it that's also acute like this, and I know that these two sides are perpendicular, then what has to be true about the two measures of these angles when you add them together? That's what that's saying. So at first blush, it might look a little bit complicated, but it really is just the stuff about perpendicular lines. So now go to this paper and let's look at number 1 and figure out which theorem they're illustrating here. It says, write the theorem that justifies the statement. Angle 1 and angle 2 are right angles based on what I was given in this diagram. They started me out with this right angle right here. How do I know that both 1 and 2 are also right angles? Yeah, that was what theorem 3.9 says. It's going to make all 4 of them right angles. Good. In number 2, I got 2 angles here. They're forming this straight line, and this is indicating that they are congruent. And the statement says that means those 2 lines have to be perpendicular. What theorem is that? It is. 3.8 says, if 2 lines intersect to form a linear pair of congruent angles, here's 2 lines intersecting, they're forming a linear pair, and the angles are congruent, then the lines are perpendicular by theorem 3.8. And I know you can guess what's coming, but why? What does this mean? What does this even? How
The
do
lines are still perpendicular.
this side and this side?
Well, they don't have to be the
Okay.
same, but they have to be.
That's true. They don't have to be the same, but they do have to be complementary, which means they add up to 90 because those 2 sides are perpendicular. That is theorem 3.10. Gee, Mr. Schoberg, this has been an awful lot of fun, but when we get to do some algebra. Right now. What's this mean right here? Those two lines are perpendicular. Find the value of x. We don't. Yeah. Yeah. We don't have to.
35.
Okay. 2x equals 70 and I divide by 2 and x does equal 35. We don't have to do all these. How would you set up your equation number 20? So x plus 25 plus 25.
Minus
X
50,
plus
X equals
50
40.
equals 9.
And how would we set up our equation number 21?
How would we, Mr. Schubert?
How would we do that? Yeah. You don't have to do all that out.
Actually,
That's all it's saying. Okay. Before we do this bottom part here, we have to go back to our bat paper and look at these last two theorems. Theorem 311, perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. If I got a pair of parallel lines, let's say, and I draw a transversal, and I know that this line is perpendicular to that first one. This theorem is saying that what has to be true about these two lines. They're also perpendicular, and take your pick with all of this stuff. What's the corresponding to this angle have to be? Which means it has to be perpendicular, or the alternate exterior has to be perpendicular, or all of that stuff. But this is saying if you, and I could do this all day long. What if I drew another one that was parallel? What has to be true about that and transversal? It's gonna be perpendicular. I could do another one right here.
This is not necessary.
It'd be perpendicular. Now look at theorem 3.12. In a plane, if two lines are perpendicular to the same line, then they're parallel to each other. So if I got a line like this, and I draw a line like this, and it's perpendicular like that. And then I come down here and I draw another line, and it's perpendicular like that. What has to be true about these two lines? Not perpendicular. They have to be parallel to each other. Because these two lines are both perpendicular to the same line, then those two lines have to be parallel to each other. What if I drew another one that was perpendicular? It'd be parallel. What if I drew another one? It'd be parallel. What if I drew another one?
yes.
They'd all be parallel. So now come to this section on the bottom of your handout. Determine which lines, if any, must be parallel in the diagram. Explain your reasoning. Okay, let's start. I heard somebody say P and Q. You're saying P and Q have to be parallel? Tell me one line that they're both perpendicular to.
Yes.
Yeah, because they're both perpendicular to S, then we know that P has to be parallel to Q. S and T are both parallel. Well, what's one line they're both perpendicular to? They're both perpendicular to Q, so I know that S has to be parallel to T. Good. What about T and U? Yeah. Do we know that U is perpendicular to anything there? No.
He was in a-
What about S and U?
You would know.
No, I don't think we know that. So just P and Q and S and T. You try number 16 through 18. They're just yes or no questions. Use the diagram to determine if those lines are parallel based on that theorem 312. You try it. Sure. I mean, see.
Well, see,
How do you say sure in Spanish?
ask your laptop.
Ask.
Ask Google Translate.
You haven't learned that yet?
No, I bet you it's C. I bet it's C or.
Certain mot, French. Yeah.
Now we have homework.
Is R parallel to S? What's the one line they're both perpendicular to? They are both perpendicular to N, which means they have to be parallel to each other. So yes. Is M parallel to N?
Yes. R,
We're both perpendicular to R, so yes. And is R parallel to T?
no.
I don't think we know that. Nothing going on there. I don't know anything there. That's gonna be a no. Can you see why we didn't take a whole day to do section 3.6?
We should have just taken it.
Yeah, right.
You're like, are we gonna have like a day?